Let's take a look at linear combinations to solve equations. These are known as systems of equations. And what we're going to do is use something called elimination. So when you have systems of equations where both equations are in the same form, these happen to all be in standard form where you have the x's plus or minus y's equals a constant, that's called standard form. And what we're going to do is we're going to try to identify which coefficients are the same that we can eliminate. So notice like both the coefficients here of the y's are 5's. Both the coefficients here are -7's. Both the coefficients here are -3's. And there will be some instances like down here where we got a +4 and a -4. And that's actually really nice when we can get something like that. But that's what we're going to be looking at when we're first starting these types of problems. So to eliminate them, I want to combine them, but if I combine 5y and 5y, I get 10y. So we want to combine them where they're going to eliminate each other. So what I'm going to actually do is I'm going to subtract this bottom equation, or basically like take the opposites of every term that's in there. So instead of 2x, I want -2x. So when I combine 6x and -2x, I get 4x. 5y and -5y, they cancel each other out. That's the whole elimination concept. And then 8 and 4 is 12. And that leaves us with an equation with just one variable, which is simple enough to solve. We would divide by 4, and x would equal 3. Now, that's not the answer, because we need the y value as well. So now that we have 3, we can substitute that into either equation. It doesn't matter. We're going to get the same thing. So I'm going to go with this top equation. And what I'm going to do is I'm going to substitute 3 in for x, and I'm going to solve that for y. So we're going to simplify, and then we have a two-step equation. I subtract 18 from both sides, and we end up with 5y equals -10. And then we divide by 5, and y ends up being -2. And this solution, x equals 3, y equals -2, is a solution because if I put 3 and -2 in for x and y, this equation would be true. And if I put it in for x and y in the other equation, it would be true as well. Now I want to jump down to this one because this is where the coefficients were opposites. So when we have coefficients that are opposites, we can literally just combine all of the like terms in these equations to come up with a new equation. So 9x and 1x is 10x. Those y's are going to cancel out. 24 and 16 is 40. And then once again, we've got an equation with just one variable. So we divide by 10 and x equals 4. And then we're going to go up to either of these equations. I'm going to go ahead and use this bottom equation. Actually, I like the top equation because there's no negatives. So I like to avoid negatives when I can. I was looking at this one because I had smaller numbers. Once again, it doesn't matter. So instead of 9x, I'm going to put 9 times 4 plus 4y equals 24. I'm going to solve this for y. So I've got 36 plus 4y equals 24. I'm going to subtract 36 from both sides to start getting the y by itself. So we have 4y equals -12. Divide that -12 by 4. And we end up with y is -3. So x is 4, y is -3. And once again, that works because if I put 4 in for x, so 9 times 4 is 36. 4 times -3 is -12, 36 and -12 gives us 24. If I put 4 in for x here and -3, I have 4 plus 12, 4 plus 12 is 16. That's why that's a solution, because it is the one ordered pair that's going to make both equations true.